Hey guys, my name is Coco and I'd like to discuss the basics of developing computers inside of Minecraft Redstone. So there's a couple of basics we got to go over first. First off, we need to understand a couple of terms, the main one being a bus and a register. So this right here is a bus. You can think of it as just a line of redstone. All it does is move data from one end of the bus to the other. So in this case, we have a simple demonstration of a button turning on the lamp at the end. So it's just a bus that moves this one bit of data all the way to the light at the end and turns it on. So that's all a bus is. And a bus just connects like two endpoints between where data needs to go. So in this case, this yellow block represents the input data, and the light represents the destination of where it needs to go. Mainly between buses, you'll find things called registers. So registers are just simple components that store a value temporarily, or in this case indefinitely with Minecraft. So it's just a very simple circuit, just like that. And all it does is it just takes whatever's on the bus and it holds on to it. So in this case, our lamp is off. In our first example, you'd hit the button, and as soon as the button turns off, the lamp turns off. In this example, you hit the button, and it flips the register on, and you can see the button isn't pushed anymore, but the register is still on, keeping the light on as well. So in this, we have a button as the input, a bus connecting that input to a register, which holds that input, and then that input going from the register down another bus to the output. And you can connect registers and buses and inputs and outputs in any way that you like. Eventually, if you connect them in a very specific way, you get a computer. So how exactly is this done? Like what combination of buses and registers and logic gates and stuff like that need to be connected in order to make what we would call a computer? So if you can imagine right now, we have two bits, the 0 bit and the 1 bit, or I guess technically it would be the 0 bit and the 1 bit. So we have two bits, two buses, and two registers going down this thing and connecting together. So we need some type of control for all of this, for all of these bits and bytes and stuff moving around, so that way we can kind of abstract these ideas of these registers and these buses out, so that way we can get a higher order of logic to develop a computer. So what exactly does that mean? Basically, it just means instead of hitting these buttons and turning inputs on and off, or taking a button and hitting these registers to reset them so that way they turn off, we can abstract out, more or less, an idea of a reset, such as a line like so, which instead of resetting each bit directly, we could reset the entire register as a single unit. So let's say we input some data, in this case 0, 1, and now we say, hey, this is our register reset. So we hit this button and that resets the whole register. And you can see that if we have both of the registers set, it still resets both of them, because it turns the lights on, turning the top redstone on, and thus the register off. So what can we do? Why am I destroying this? What can we do with this type of thing? more or less. What we could do is we can kind of daisy chain these together in a way that we can move data in kind of a cyclical motion. One more thing I need to mention is we need some type of another thing in between these buses. I'm not too sure an exact term for them, but it's some type of like data control. So it's, instead of allowing data like a bus, it would restrict data. So if you can imagine, we have two lines, or we'll just do one for now. So we have one bus of input, and we need to be able to determine if we want that input to go through or not. So what we could do is we can invert it and invert it again, and if we power that middle inverted, then this now becomes the control. So let's say that this, I guess I'll do it correctly and turn on the button and turn on the register, which powers the bus. And so if this line is powered, you can see that this redstone torch is still powering the redstone, and thus the output going to the output bus is still off. Just like so. But if we enable the control, which will allow this data to flow through, you can see that that data passes through to the light. And then of course we can abstract this out one layer, and we can make an entire control block for this. And all we do is we power everything unless a button is pushed. And that will let all the data on the bus through this little control block to the outside. So if we build out our 2 bits that we have, now you can see we have input connected by a bus to a register. That register connected by a bus to some type of control block to restrict data or enable data. And then of course a button which allows that data to flow through that control to the output. Cool. So from there now we have all the parts necessary to build the core infrastructure of a computer. So I'm gonna go through and I'm gonna make a very simple little 2-bit structure here, and then I'll come back with you guys when that's all completed, and we can explain exactly how these components allow us to develop more complicated systems. So enjoy the time lapse. Awesome. So welcome back. Hopefully you enjoyed watching me do that. Oh, I forgot a couple of very important reset lines here. Whoops. There we go. We gotta be able to reset our registers, you know. And so what I've done here is I've just made a very simple kind of circle of buses and registers and stuff like that, so that way we could see exactly what we can do with this type of configuration. So right now the system is empty. You can see that these registers are empty. These registers right here are empty. All the buses are empty. So let's go ahead and just input some data. I'm gonna just put in 1. So we have 1 in the register, and we'll call this our input register for now. So you can see that we've set our input register, and now what can we do with all of these buses and buttons for resetting and control lines, and like what exactly does this mean? Well, you can see that on the output bus of this register we have the 1-bit on, as we would expect, and that's feeding into 2 different control blocks, and those 2 control blocks are feeding into 2 different registers. So now we have a cool decision where we can decide where we want to put that data. So we have a number 1 on our line, and let's say we're going to put that into, we'll call this register A. So we're going to say let's put this into register A, and you could see that what we did is when we hit this button, these lights turned off, allowing the data to pass through the control block and turn this register on. which is super cool. So now what we can do is we can reset our input, which is now at 0, and we can see that our register A is still at 1. So these registers act as just a very short-term memory that we can use to pass data around our computer. So we've inputted 1 into register A. Let's put something else into register 2. Let's put 3 into register 2. So we've inputted 3 into our input register, and now what we're going to do is we're going to activate this button for the control line for register B. We'll call this register B. So when we hit this button, again, same thing, it's going to turn on this light, turning off the redstone, allowing this number 3, represented by those 2 on bits, to pass through this control block into the register. Bam, worked perfectly. I'm surprised. Usually I miss a torch or something, and you can imagine with bigger projects it gets really hard. But that turned on these registers, so now you can see that we have a 1 in our A register and a 3 in our B register. And now that we're done with the input, we can go ahead and clear out the input register so that way we can do whatever we need to with this. And now I've just done something really simple, where instead of going to any complicated logic gates or anything like that, I'm just having, again, 2 more control blocks back here that just pass the data all the way back into the input. So if we say, hey, let's get our A register data back over to our input so that way we can move it somewhere else. Okay, let's say we don't care about that 3 anymore and we want to copy this 1 into the B register. So what we could do is we can allow, using this control block off the output of the register, through the control block onto the bus back here through this button, which allows us to control that number 1 being passed out, back through all these repeaters back to the start, and you can see that our number 1 is back into our quote-unquote input register. Okay, super cool. And now let's say we want to continue our operation of copying A into B. So we have 1 back in our input register. And what we're going to have to do is we're going to have to clear out anything already in the B register. So we'll go ahead and just clear that. And then we just want to pass this number 1 through the control block into the B register. And voila, we've copied A to B. So this is the power of these buses and these control blocks and all this kind of stuff. It might be a little bit quick. I'm not going into how Redstone works or anything. Just the main mechanics that allow us to kind of extract ideas and concepts out of these things. So instead of working with individual bits, we say, hey, let's just move this byte somewhere, okay? And then from there we can go, hey, instead of saying, hey, I want to run around and hit all these buttons to do this stuff, we can have 1 button that just hits the buttons in a correct order to allow a certain function. So let's go ahead and implement something that does that real quick, and then I think we'll be done with this episode. So let's go ahead and continue with the same idea that we had, where we just want to copy A into B. So we need a singular button that will take whatever is in register A. Let's go through our order of operations that we need to conduct. So we need to take register A, and we need to move it to the input register. First, we should make sure that's cleared. So our first operation should be to clear the input register. Okay? And then our second operation should be setting that input register to the value of A, using this button right here. That'll pass the data through into the input register. And then all we have to do is we have to clear out whatever's in B. Okay, easy enough. We have a button for that. And then we have to pass in the data from the input register into B. Bam, too easy. We've done it again. It's the same data, but you can see how that went through. So now all we have to do is we have to wire up these control lines in a specific order to allow us to have a 1 button that'll allow us to do that. So again, we started over here with the input register and clearing that. So let's make this in cyan blue. So let's just say we have our 1 button right here that's going to do all of these things. I'm going to go ahead and switch this over to the other side just for ease of use. And now let's take from this button a line that goes into there. So if we hit this button, this is just the same thing as hitting the clear input button, okay? And then the next thing we want to do is we want to pass this data from what is it called? The control block on the output of register A back over into the input register. So the next thing we want to do, what we'll do is we'll represent everything with a full second of delay. Or half a second, I guess. I don't want to put that many repeaters down. And this line's just going to come over here. And it's going to hit essentially that line on, allowing it to go through. So that's our next operation right there. Okay, so let's try this out. So let's assume that we have data already in the input register. When we hit this button, we want it to clear the input register and then pass the data from the output register back into here, and you can see that we have our 1 data represented from our A register. And now the next thing we want to do is we want to I'm sorry, I got a bit slow there. We want to clear out whatever's in the B register to prepare it for whatever we want to pass into the B register. So let's, this is going to be kind of messy wiring, but you can kind of see how we're gonna do this. It's, again, really messy, and this isn't how it should be done, but that's how I'm doing it. So, yeah. So, what we want, let's put that button up there. And again, we want, let's say, a half-second delay on here. And that's going to come over here, and that's going to clear out whatever's in register B. And then from there, we just want to how do I want to do this? We'll go like that. Again, with a half-second delay into setting whatever's in B from the input register. Okay, so you can see how we kind of have this cyclical thing that we have to do in order to move A into B. So let's go ahead and set some random data into B, because we want to make sure that it works correctly. Now you can see that we have a number 3 in register B and a number 1 in register A. Now if I've wired everything up correctly, when I hit this button, again what we're going to do is we're going to clear whatever's in the input. We're going to take whatever's from register A and move it into that input register. And then we're going to clear whatever's in the B register and set whatever's in the input register into B. I hope this all goes well. After this, we expect to see a number 1 written into the B register. And just like that, we have a number 1 in the B register. So this is now how we can use all these buttons that we've created to move data around to then allow for specific commands and specific operations to be run on our quote-unquote computer. We're not computing anything here, but it's a collection of buses and registers and control blocks. So that way we have a single button that'll perform a function with whatever data is in the system. And that could be, more or less arguably a computer. So this is a very primitive form of what goes on in real computers, and also what we use to emulate computers inside of Minecraft with Redstone. So it's all these kind of structures that are connected together, and then of course we have different arithmetic logic units and different types of things that can affect that data to, again, perform more advanced functions. This is just a very brief look at what what's required to build a computer inside of Minecraft. I hope this helps. I'll see you in episode 2.